we're going to talk about the Python input function. I'm going to use the word function a lot in this class, and I haven't quite described what a function is yet, and we'll get to that. But in general, if you see anything that has parentheses and then something in it, that's a function. So, you think math and you have like f of x equals 2x plus 5. Like the f of x has like an input in parentheses. Same kind of structure in programming. So a function that we've already seen is print. Because I have print, I have these parentheses, and this is a function. So, of course, every rule doesn't apply in 100% of the circumstances, but generally, if you see parentheses with some sort of value inside, this is a thing called a function in programming. So, an input function allows user input to be given. I'm going to see how this works in the terminal. So say I have x equals, and then I say input, enter your name. You'll see when I hit enter, I'm prompted to enter my name, and then I'm going to say Amy. That's my name. So what this has accomplished is now if I look at the variable x, so I'm going to do print x. In the terminal, I can technically just put the variable x and it will tell me the value. But when you're coding things, you have to put print or some sort of other output function to see the value. So I'm going to try to follow that practice so that you get that. So if I say print x, you can see it stores the value Amy. This is, again, something we'll go over in more depth later, but x has a value Amy, and of course this is a string. So this type function is telling me what type this is, because we talked about there's like integers, there's floats, there's booleans, there's strings, there's characters which basically get treated like strings in Python. So the type function will do a module where this is like formally taught, but if we do the type function, we'll see it says class string, and that's telling us the type. So the reason I am telling you this is maybe I want to say, okay, x equals input, enter your favorite number. That's a mess. We need quotes, and I want to use a different variable because x was already used. If I reuse the variable x, all it does is rewrites over the previous value for x. So it's good to keep different variables just so you don't write over some information if you need it later. So enter your favorite number, 23, and then we'll have z equals input, enter your cat's age. And my cat data is 8 now. So now I have in the value y, the number 23, and in the value z, the number 8. I'm going to use this type function, and I'm just going to do type y. So although I've taken in a numerical value, we have to be a little bit careful if we want to do math on these, because Python, whenever we use the input function, it just assumes that everything taken in from the input function is a string. And that can be problematic. We know that if we add two strings together, concatenation is what happens. If I do hi plus my name is Amy, it'll make the string hi, my name is Amy. If I take in two numbers and I want to get the sum for you, so I add them, it does 238 as a string because it's just concatenated them, because the input function always views things as strings. So this is, using the input function itself isn't so bad, just getting some values. But the biggest thing to be aware of is we're always forced into the data type of string. So there are some things we can do to resolve this. I could say y equals int y, and z equals int z. It appears that nothing has happened when I've done this. However, as you can see, if I use the type function, this has made y and z into integers. So sometimes this is called typecasting. And again, the actual formalities of typecasting we'll get into detail more later, but using the input function, we need to know basic typecasting because everything's read as a string. So this is called typecasting, where we change the value, or we change the type, I mean. So now I've changed both of these to integers. And now if I do y plus z, it adds them as we would expect. Y plus z is giving me a value of 31, which is what we want. Usually when you're adding integers, you want it to be the sum of those integers. 23 plus 8 is 31. So this is just something you have to be very aware of. And with practice, you'll become more aware of it, because when I added the two strings, it's not like it gave me an error or said invalid output or anything like that. It was just like, okay, here you go. Here's a new output. And then, you know, if you make it into an integer later, then you're working with a completely wrong number, and that obviously is very problematic. Some programming languages, so here's 2 as a string and 3 as an integer. Okay, good. Some programming languages, if you add a string that's a number and a number, it sometimes changes the whole thing to a string or the whole thing to an integer. And that can be very problematic because then you don't even know what type your stuff is. So at least Python gives you an error there. Sometimes getting errors with your program is going to seem very irritating, but they're very helpful because it's better to know where something is wrong rather than having to be like, okay, where did my logic go wrong, and go through the whole entire thing. We can also convert to floats in the same way. So I could do y equals input, let's see, exactly how many degrees is it outside? And 5.6 degrees Celsius. So here, if I were to make y into an integer, this is going to be a problem because I won't preserve all of my information. If I did what I did before and I say y equals int y, well, integers don't deal with decimals, right? So sometimes, like in the other case, I knew I was putting in whole numbers. You've assumed my favorite number was probably a whole number. If you think someone's putting in whole numbers, you can use int. Ints are nice, they play nicely in some ways, they don't round, and they take less memory. There are advantages to using integers. However, in a case like this, we have a decimal which is of type float. So if I want to make my string, 5.6, into a numerical value, then I have to go ahead and change it into a float, which again, as we said last time, is the type that has a decimal place instead of just a whole number. And then y now has the value 5.6, and the type of y is a float. So this is another typecasting, but int and float, using them as functions around your variable, will change the value. If we put y in now, it's still float. If I put in z, it's a string, 5.6. Usually you know if something's a string because it has those little quotes around it sometimes. So if I were to say float z, you'll see it gives me a float, 5.6, but I haven't changed the value of z to be a float, right? Like if I still type z, it's still a string. So we have to do z equals float of z if we want to make sure we change the value to a float. So if you just say float z, that actually could be useful if you just want to mostly keep something as a string, but in one scenario you want to use it as a numerical value. But a lot of people will make this mistake of just saying float z, I want to make it into a float, and then it's not, because it just made it into a float for that one line, but it's not making z as a variable into a float. So we have to do z equals float z, and then z now has a numerical value. So one other technique that we can do for this is I've been taking the input and then converting it to like an int or a float or whatever. I can do something like, I could say a equals input, okay, enter your cat's age, and it'll do just what we did before. It takes it as a string and then we can make it into an int. We can do all of this in one step if we want. So you can say int input enter your cat's age. So it is okay to stack functions or compose functions, to use the mathematical word, to compose functions within each other. So now if I enter the cat's age as 6, which is not true, then a is automatically an integer. So we can wrap this all into one thing. And this obviously has its advantages. It's sleeker, it's easier to read from a coding standpoint. The problem is, if we do something like this all at once, and the user says something like, my cat data is 8 years old, it's just not going to be able to make that into an integer, right? It's just going to be like, what do I do with all of that information? And then it'll stop with an error. So obviously, if we just tried to cast that as an integer later, it would also give us an error. But doing the input and then later changing the type, as you do more advanced applications, this will allow you to do some checks on it. Like before you wrap it with the integer function, you can ask like a dot is digit. That's brutal. So it gave an error, but it still did actually make a into an integer. It's just a confused integer. This is the danger of doing the wrappers. Like if you know that what you're going to get is just going to be straightforward, or you're expecting a specific type, that's fine. And in some scenarios, the user is going to know or expect to put input in a certain format. You fill out forms all the time that say enter your birthday as month / day / year. Like they give you the format ahead of time. So there are reasons to do that for formatting, but it can ruin the code flexibility. So you just have to be aware of that. And yeah, that's so confused because it's not even like a is a string anymore. It is just an integer, but not defined. So I'm going to go back to doing a enter your cat's age. I'm going to write some nonsense. Not nonsense, but is 8 years old. And then hopefully I did mean is digits. Okay. Then I'm going to type a dot is digit, and you'll see it gives me a false. So this is just a way of I wrote in a string, my cat data is 8 years old, and there are ways to check like, oh, did the user give me a numerical input, so that you can know that before you try to make it into an integer and have your whole program blow up. There are ways to do different checks. The reality is, and again, we'll get into this user stuff later, reality is what you would end up doing is you would say, oh, you'd prompt the user again. You would say not in the correct format. So it's nice to be able to check things and then ask for things in the correct format. So that was maybe kind of a lot, but the morals of the story here are that the input function takes in user input in a very rudimentary way that obviously you would tie into more advanced applications in other ways. It always takes in user input as a string, even if you type a numerical value, and you can change that string to an integer or a float by using int and then putting the variable name in there, or using float and putting the variable name in those parentheses. And you can actually do what I had done above and wrap the whole input function into an integer to have it automatically cast the input into an integer to begin with. But that comes with warnings of you need to be sure that the user is going to give you correctly formatted data, because if it doesn't, you run into issues. And that's great for small programs. It's great for small programs. Readability is up. All these things are up. For programs that you want more flexibility with, like, checking if the user put the stuff in the correct format, you can use different functions to check the formatting. It's nice to not necessarily wrap it with float or int right away, so that you can then make some decisions before you attempt to change them into floats. The other thing is that if we want to change, maybe we have a variable b, if we want to change it to an int, you don't want to just say int b, because that's only going to change it to an integer for that one line. You want to say b equals int b, or b equals float b, and what that does is that it makes sure that b gets assigned to this new value that has a new type. So that's the other thing to be careful of, otherwise you will lose the fact that you had made it into an integer. And then you often need to do this before doing mathematical functions, or you might get an error or things might mess up.